Have you ever wondered what lies at the heart of a black hole? These mysterious regions of space have fascinated humanity for generations, sparking countless questions and theories. Imagine a place where gravity is so strong that nothing, not even light, can escape. This immense gravitational pull creates a point of no return, known as the event horizon. These cosmic abysses, known as black holes, have captivated scientists and stargazers for centuries. From Einstein's theories to modern-day research, black holes challenge our understanding of physics. Join us as we journey into the depths of these enigmatic objects and explore what happens when something ventures too close. What secrets do they hold? What mysteries lie beyond the event horizon? In this exploration of the cosmos, we'll unravel the mysteries surrounding black holes. We'll look at how they influence the galaxies around them and their role in the cosmic dance of the universe. We'll delve into their formation, their defining characteristics, and the cataclysmic events that give birth to these fascinating phenomena, and the mind-boggling effects they have on space and time. From the warping of space-time to the incredible energy they emit, black holes are a testament to the universe's power and mystery. Black holes are born from the remnants of massive stars. When these stars exhaust their nuclear fuel, they can no longer support themselves against their own gravity. The core collapses inward, creating a region of infinite density known as a singularity. The singularity is at the very center of a black hole. It's where all the matter is compressed into an infinitely small point. Surrounding the singularity is an invisible boundary called the event horizon. The event horizon is the point of no return for anything that crosses it. It marks the boundary around a black hole beyond which nothing can escape. This invisible line is where the gravitational pull becomes so strong that escape is impossible. Once something passes this boundary, it can never escape the gravitational pull of the black hole. This includes stars, planets, and even entire galaxies that stray too close. The immense gravity pulls everything inward, crushing it into the singularity at the center. Not even light, the fastest thing in the universe, can outrun a black hole's grasp. The gravitational force is so intense that it warps space and time, bending light around it and creating a phenomenon known as gravitational lensing. Imagine falling into a black hole. As you get closer, the gravitational forces would stretch you out in a process called spaghettification. Your body would be elongated and compressed at the same time. As you approach the event horizon, time would slow down for you relative to an outside observer. This means that while you might feel like only a few moments have passed, years or even centuries could have gone by for someone watching from a distance. This phenomenon, known as time dilation, is one of the strange consequences of Einstein's theory of general relativity. It shows how gravity can affect the passage of time, making it a fascinating and mind-bending aspect of our universe. As you fell deeper into the black hole, the gravitational forces would become increasingly extreme. The immense pull would stretch and compress everything in its path, creating a surreal and terrifying experience. The closer you get to the event horizon, the point of no return, the more intense these forces become. You would experience a process called spaghettification, where the difference in gravity between your head and your feet would stretch you out like spaghetti. This phenomenon occurs because the gravitational pull is so much stronger at your feet than at your head, causing your body to elongate and thin out. It's a dramatic and fatal transformation that highlights the sheer power of black holes. While we can't observe what happens inside a black hole directly, scientists believe that the singularity is a point of infinite density and curvature in space-time. This singularity is where all the mass of the black hole is concentrated, creating a region where the gravitational pull is infinitely strong. It's a place where our current understanding of physics breaks down completely. The laws of physics as we know them break down at the singularity. The extreme conditions near a black hole challenge our understanding of the universe, pushing the boundaries of science and sparking endless curiosity. What lies beyond this point remains one of the greatest mysteries in astrophysics, a true journey into the unknown. Black holes remain one of the most intriguing and enigmatic objects in the universe. They challenge our understanding of gravity, space, and time. While we have learned much about these cosmic abysses, there is still much more to discover. Want to explore the universe further? Click on the link in the video description and discover many essential travel products that will help you organize a happy trip for you and your family.